Hello my dear students, welcome to today's lesson. So I'm going to do the exercise and some more extra questions related to work, energy and power. We have discussed this lesson. What is work? An object is said to have done work if its position changes or the shape changes due to an applied force. That is what we said as work. And the unit of work is joules. And then we discussed energy. What is energy? The ability to do work. And under that, we saw there are different forms of energy. For example, sound energy, light energy, heat energy, magnetic energy, and mechanical energy. We discussed mechanical energy in detail. So there we saw there are two types of mechanical energy, and they are potential energy and kinetic energy. Potential energy is the energy obtained or stored in an object due to its position or its shape. So there again we discussed two types of potential energy. The gravitational potential energy, that is the potential energy gained by an object if there is work done against the gravity. Then the elastic potential energy. There is the potential energy that is stored in an object due to the elasticity. When a spring stretches, there is elastic potential energy stored in it. Then if the object is in motion, due to its mass and velocity, there is the kinetic energy. So those are the two types of mechanical energy. After that we discussed the power. Power is the rate of work done or work done in a unit time. So those are the topics we covered under this lesson. I'm sure you all have a good understanding and I'm sure you have already answered these questions. If not, answer them by yourself first and then you can check your answers with my discussion. So I'll start off the chapter with the miscellaneous exercise from your textbook. The first one. First part of the question, a child lifts a bag of mass 4 kg to a height of 1.5 meters. What is the work done? And the gravitational acceleration is given to you. So if there is a bag, I'll just draw it as a cube. So if we consider this as a bag and the mass of the bag is 4 kg, and the child is going to lift it to a certain height, say to this point, up to this point. And this height is going to be 1.5 meters. So here you can see the gravitational acceleration g, that is 10 meters per second square, that is acting downwards. So the child is lifting the bag up. Then what happens? She is doing work against the gravitational acceleration or the gravitational force. So because of that, there will be work done when the bag is lifted from here to here, and that work done will be stored as what? Gravitational potential energy. I'm sure you're familiar with that. Right. So if we look at the question, a child lifts a bag of mass 4 kg to a height of 1.5 meters. What is the work done? So what is work done? The magnitude of force applied multiplied by the distance moved by the object in the direction of the force. So here we know the mass of the bag, that is 4 kg. So what is the force that needs to be applied? It is mass into gravitational acceleration. So if we write down the answer for the first question, mass of bag, that is 4 kg. So weight of the bag. Weight of bag, that is going to be what? Mass into gravitational acceleration. You know the equation, Newton's second law of motion. F equals ma. From that we get W equals mg. W is weight, m is mass and g is gravitational acceleration. So here it's going to be 4 kg into gravitational acceleration 10 meters per second square. So what is the weight? 40 newtons. So this is the force that needs to be applied so that the bag can be raised from here to there. That is a height of 1.5 meters. So if we write that down, force required to lift the bag, that is 40 Newton. Then we know the height lifted. Height lifted, it's given to you as 1.5 meters. So the work done is going to be what? Force into height lifted. You can write it using symbols or you can write it in words. Here if you want, you can say magnitude of force multiplied by height lifted. Both are fine. So there, the work done is going to be 40 Newton multiplied by 1.5 meters. So if you multiply that, what will happen? You will get the answer as 40 into 1.5, 60 joules. Or if I write the units, Newton meters, you all know Newton meter is equal to joules. So that's going to be 60 joules. So here students, I have written down all the steps in detail. But you all know when you are answering these types of questions, you don't have to write each and every step. As long as you know what is happening there, you can directly write work done. First you can calculate the force required to lift the bag to a certain height. That will be 40 Newton. And then you can say work done equals magnitude of force into height lifted. And then you can do this calculation. If we go back and check. So this is what we needed to calculate. The mass of the bag is given 4 kilogram. Weight of the bag is m into g. So that's 4 kilogram into 10 meters per second squared. That's 40 Newton. And therefore, the force required to lift the bag will be 40 Newton. That is against the gravity. And the height lifted is given to us as 1.5 meters. So therefore, the work done is going to be F into H. F is the magnitude of force and H is the height lifted. So if you substitute there, you can see 40 Newton into 1.5 meters. That will be 60 Newton meters. That's equal to 60 joules. Here again, students, for you all to remember and recall what we have learned, I have written this step as well. Newton meters, that is equal to joule. So for the exam or when you are answering questions, you can go from this step to this step directly. You don't have to always show all these steps. This step can be skipped. That is fine. As long as you remember that Newton meters is equal to joules. When 1 Newton force is applied and if the object moves to a distance of 1 meter, the unit is defined as joules. That is, the work done is 1 joule. I'm sure you can remember that. Then if we look at the second question. If the child took 3 seconds to do the work above, what is the rate of doing work? That is power. So the work done in a unit time or the work done in 1 second is considered as power in watts. You can remember that. Joule per second. Joules is work per second, unit time. So the unit for power is watts. Joules per second is equal to watts. So that is what we need to calculate here. So we can say second one, work done 60 joules, work done, then time taken 3 seconds, So power is equal to work done divided by time. That is equal to 60 joules divided by 3 seconds. So 60 divided by 3, 20 joule per second. That is going to be 20 watts. So here again, you all have to remember, students, joule per second. Joule second minus 1 is equal to watts. That is the standard unit for power. So power of the child when she lifts the bag to a certain height is going to be 20 watts. I'm sure you all can understand that clearly. So here again, work done 60 joules, time taken 3 seconds, and power is equal to work done divided by time. So here, if you divide 60 joules by 3 seconds, you get the answer as 20 joules per second. That is equal to 20 watts. So with that, students, we'll move on to the next one. Right. The second question. A mass of 800 grams was projected vertically upwards at a velocity of 20 meters per second. So you have a mass that is 800 grams and it was projected upwards with a velocity of 20 meters per second. So what will happen here? First, try to understand the situation. Normally, when you throw an object upwards, project an object upwards, the gravitational acceleration is going to be down. Gravity is going to be 10 meters per second square. So that is acting opposite to the velocity. So what happens there? The object is going to decelerate. So here, object will decelerate. You can remember that. We have done that with linear motion in a straight line. So object will decelerate because the gravity is acting downwards and the object is moving upwards. So what will happen? It will reach a certain height where the velocity will become 0. That will be the maximum height. So this is at maximum height. Because the object is moving upwards, it's going to decelerate and it will reach a maximum height when the velocity becomes 0. Thereafter, you all know it will move downwards. Once it becomes 0, velocity 0, then the gravitational acceleration will act on the object. So the object will come down. You have seen this. When a batsman hits a ball up, ball goes up, reaches a certain height, then it comes down. So like that, you have seen so many examples. You might have thrown things upwards, projected things upwards. They come down. So that is the motion here. Question. What is the kinetic energy of the object just as it is projected? So at this point, velocity is 20 meters per second. What is kinetic energy? Energy of an object due to its motion. That is the mechanical energy of an object due to its motion. And you all know the equation. What is the equation? E, kinetic, to denote its kinetic energy. We write the equation as half mv squared. So half m is the mass of the object and v squared, that is the velocity into velocity. And what are the units? Mass should be in kilograms and velocity should be in meters per second. So if we substitute the values, you can get the kinetic energy. Here you can see, students, the mass is given in grams. So what do? You need to convert it to kilograms. You have to divide it by 1000. Again, like I normally say, you can either do the conversion. So if you divide 800 by 1000, you will get the answer as 0.8 kilogram and you can substitute the value here, or else you can directly substitute with the unit conversion and do the calculation. So I am going to use the second method. Here half into m 800 divided by 1000 kilogram into velocity 20 meters per second into 20 meters per second, because it's v squared. So then if you simplify, here you can see half into 0.8 into 20 into 20, that will be again in joules. Work done, energy, all are in joules. The standard unit of energy is also joules. So here we can simplify this. 2 and 20, 10. So they are 0.8 into 10, 8 into 20, 160 joules. That is the kinetic energy possessed by this object. I'm sure you all can understand that and you would have answered this correctly. Let us go and check again. So this is what happens there. The object is projected upwards. It goes up with a velocity. So if we are to calculate the kinetic energy, this is the equation we use. E kinetic equals half mv squared. So half into, we need to do a unit conversion. It should be 800 divided by 1000. So that is 0.8 kilograms into velocity because it's v squared. So when you simplify, you get the answer as 160 joules. Then the second question. How long will it take to reach the maximum height? How do you find that? How long will it take to reach the maximum height? What are the information you all already know? You know the initial velocity of the object. But from the knowledge you have, you know when it goes to the maximum height, the velocity is going to be 0. So then you know the gravitational acceleration 10 meters per second square. I'm sure you can remember the equation. Acceleration is equal to final velocity minus initial velocity divided by time. Why? Acceleration is rate of change of velocity. So we will have to use that equation to calculate this. Second one, acceleration equals change in velocity divided by time. So when we say change in velocity, what is that? Final velocity minus initial velocity divided by time. So here, students, you all can remember, now the object is here. It is moving upwards with a velocity of 20 meters per second. And here the velocity will become 0. And that is going to be the maximum height. And when this happens, since the gravity is acting downwards, it's going to be deceleration. Gravity downwards, so deceleration. What is deceleration? Minus acceleration is going to be deceleration. So here for acceleration we need to have a negative value. That is what we need to substitute there. So here acceleration is minus. So final velocity minus initial velocity divided by time. So minus 10 meters per second squared is going to be equal to final velocity 0 and initial velocity, and there you all can remember, students, the final velocity minus initial velocity, 0 minus 20 meters per second divided by time. So this is what we need to calculate. So here we need to rearrange this equation. So you take t as the subject, that is time, is going to be equal to minus 20 meters per second, that is the part here, divided by minus 10 meters per second square. So you can easily cancel off the negative signs, minus minus. So 20 over 10 seconds. That is going to be 2 seconds. So time taken for the object to reach the maximum height is going to be 2 seconds. Is that clear to you all, students? So if we go back and check, this is the calculation we did. Initially we found the kinetic energy. Then how long will it take to reach the maximum height? For that we had to use the gravitational acceleration. Acceleration equals change in velocity over time. That is final velocity minus initial velocity divided by time. But when we say acceleration, here since gravity is acting downwards, it becomes deceleration. So the value should be a negative value. That is why minus acceleration equals final velocity minus initial velocity divided by time. Here I use VF to show that it is the final velocity and initial velocity VI. So minus 10 meters per second squared is equal to final velocity here is 0. Initial velocity is 20 meters per second divided by time. And when you rearrange, you get it as t equals minus 20 meters per second divided by minus 10 meters per second squared. That is equal to 20 divided by 10 seconds, that is 2 seconds. So it takes 2 seconds for the object to reach the maximum height. I am sure you all can remember that and you would have done this calculation correctly. So then, we'll move on to the next question. Third one, what is the maximum height it would reach? So we already calculated the time taken. How can you relate it to the maximum height? This is also again from your one of the previous lessons, motion in a straight line. What is that? Maximum height is the displacement, and when an object is moving under uniform acceleration. So here, although it is deceleration, it's still uniform. So when it is uniform acceleration, how do we calculate displacement? Displacement is equal to average velocity into time. And what is average velocity? Initial velocity plus final velocity divided by 2. So that is how we calculate the maximum height. So there, if we write it, maximum height is equal to average velocity into time. So that is equal to 0 plus 20 divided by 2, that is meters per second, into time we already calculated as 2 seconds. So here you will have the value 20 divided by 2 into 2. So that is going to be 20 meters. Is that okay, students? So to find the maximum height, we need to have average velocity into time. What is the reason? Because the object is moving with uniform deceleration. So if you want, I will write it here. Object moves with uniform deceleration of minus 10 meters per second squared. So because of that, we use this equation. There are two equations to calculate maximum height. This is the equation used when the object is moving with uniform acceleration or uniform deceleration. So average velocity into time, you get the answer as 20 meters. Then, the next question, what is its potential energy at the maximum height? What is potential energy? Here the work is done against the gravity. So this is gravitational potential energy, mass into gravitational acceleration into height. So if we write the equation, potential energy that is E potential is equal to mgh, mass into gravitational acceleration into height. So to calculate E potential, you need the mass. If you can remember, if you go back to the question, you can see here, students, 800 grams. So we calculated the mass in kilograms as 0.8 kilogram. Here you can see we have calculated it as 0.8 kilogram. So there, we need to calculate potential energy, E potential, 0.8 kilogram into G is 10 meters per second squared, and the height, we calculated the height as 20 meters. So that is what we have calculated here, 20 meters. So then, if we calculate the potential energy, 0.8 into 10 into 20, that is going to be 160 joules. Is that clear to you all? Now there is something you all have to remember, students. Can you all remember, when an object moves, there is energy conversion. Usually the kinetic energy can be converted to potential energy. Potential energy will be converted to kinetic energy. So if you remember, we have calculated the kinetic energy. Here you can see we have calculated the kinetic energy. What is the value we have got? 160 joules. Now here we have calculated potential energy. That is also 160 joules. So what has happened there? When you project the object upwards, initially due to the velocity, it is kinetic energy. And when it reaches the maximum height, the velocity is 0. So there is no kinetic energy. But all that kinetic energy has been converted to potential energy. I have explained this before also to you all. So if we put that in a diagrammatic form, these are the calculations you all need to do just to recall what we have done before. Here you can remember, if there is an object here, there is the object there. Here velocity is 20 meters per second and here the velocity is 0. So when the object goes from here to here, what happens there? Here we have kinetic energy that is equal to 160 joules. Here we have potential energy that is 160 joules. So this kinetic energy has been converted to potential energy. So at this point, what is the kinetic energy? That is going to be 0. And here the potential energy is going to be 0. That is considering this as the basic level. This has 0 height, then there is no potential energy, there is only kinetic energy. And all the kinetic energy has been converted to potential energy. So at this point, since velocity is 0, E kinetic is going to be 0. Is that clear, students? This is something you have already done, and with the calculation also, we were able to understand that clearly. So I am sure you can remember this conversion, energy conversion or transformation of energy. So with that, students, I will move on to the next slide. This is the third question. A child of mass 35 kg climbs up a staircase to a vertical height of 4 meters. So here you can see a child is climbing up a staircase, but he reaches a height of 4 meters. What is that height? Now this is the vertical height. You have to remember from this point at the bottom of the steps up to that point. So there, that is the vertical height. Vertical height. Vertical height is how much? 4 meters. So although the staircase is this way, he is climbing up in an inclined plane. You all can remember that. But still, the vertical height that is changed is from the bottom of the staircase to the top of the staircase. And always, when we consider potential energy or the work done, you can remember it is the vertical height that we consider. The mass of the child is given as 35 kilograms. Here you can see 35 kilograms. The first question. What is the amount of work he does? So that is what we need to calculate first. First one, to calculate work done. What are the values you need? Work done is magnitude of force into the distance moved in the direction of the force. So here the child is going to move against the gravity. So the work done is going to be the weight of the child. So that is what we need to find first. Mass of child 35 kilogram. Then weight of child. Weight of child, what is it? Mass into gravity. 35 kilogram into gravitational acceleration 10 meters per second square. So that is going to be 350 Newton. So what is the force exerted? That is going to be 350 Newton. Force exerted or force applied 350 Newton. Distance moved, that is given to us as 4 meters. So therefore, work done. Force into distance moved. So that is going to be 350 Newton into 4 meters. Again, if you calculate 1400 Newton meters, or that will be equal to 1400 joules. Is that clear, student? So the work done. Again, if we look at it, although the child is climbing up the stairs like that, 35 kilogram mass, vertical height is 4 meters. So to calculate the work done, we know the mass of the child 35 kilogram. Weight of the child needs to be calculated, mass into gravitational acceleration, that is 35 into 10, 350 Newton. That is the force exerted to do the work, to climb up the stairs. Distance moved is given as 4 meters. So work done, force into distance moved, 350 Newton into 4 meters. That is going to be 1400 Newton meters or 1400 joules. I am sure you have got that same answer. So with that, if we look at the second question. If he took 1 minute to climb the stairs, what is his rate of doing work or power? What is the rate of doing work? Work done in a unit time, but there the work done has to be in joules, but the unit time has to be in seconds. So here it's given as 1 minute. So we need to convert it to seconds. 60 seconds equals 1 minute. So for the second question, here, work done 1400 joules, time taken 1 minute, but that is equal to 60 seconds. So, power work done, time. So that is going to be 1400 joules divided by 60 seconds. So if we simplify that, 140 divided by 6 joules per second. So if we simplify that, students, 140 divided by 6. So that is 2 times 12, 20. So that is going to be 3 times 18, again 2. So 20, 18. It will keep on going as 23.33. So I will take it as 23.3. So here it is going to be 23.3 joule per second. That will be 23.3 watts. That is the power of the child. I am sure you all have done this calculation correctly. So if you go up and check again. The first question was to find the amount of work done. The mass of the child is 35 kilogram and the height reached, that is after climbing the stairs, is 4 meters. So from there you can see we calculated the work done as 1400 joules, and then to calculate power we had to divide work done by time. So work done is 1400 joules, and since the time is 1 minute, it has to be converted to seconds. So 60 seconds. When you divide 140 by 6, you get 23.3 watts. That is the power of the child. I am sure you all have also calculated this correctly. So with that, students, I have completed the questions in your textbook. So with that, students, I have completed the questions given in your textbook. But in addition to these questions, I am going to discuss some more extra questions with you. Extra question 1. Underline the most suitable answer. So you're familiar with these types of questions. These are the MCQ type questions or multiple choice questions. You have 4 answers. You have to select the most suitable answer and you have to underline the answers. The first question. There are 2 types of mechanical energy. What is mechanical energy? There are 2 types. This is when an object changes position, when there is a work done, or when it is moving due to its velocity, the energy possessed by an object. And there are 2 types. If the position changes or the shape changes, the energy stored is the potential energy, and if the object is moving due to its velocity and mass, it has the kinetic energy. So the 2 types are potential energy and kinetic energy. Let's look at the answers. Magnetic energy and potential energy. Magnetic energy due to magnetism. That is not a mechanical energy. But potential energy, yes. Heat energy and potential energy. Heat energy actually leads to temperature. That is not mechanical energy. But potential energy is mechanical energy. Electric energy and kinetic energy. Again, electric energy, when electricity flows through a conductor, there is electric energy. But that is not mechanical energy. But kinetic energy is a type of mechanical energy. The last answer, 4th answer, potential energy and kinetic energy. Both of those are forms of mechanical energy. So the 4th answer. Then the second question. What is the name given to the energy stored in an object due to its position or shape? I just mentioned that to you all. Out of the two types of mechanical energy, the energy stored in an object due to its position or shape is known as potential energy, whereas kinetic energy is due to the velocity and mass of the object. So here the answer should be potential energy. First one, potential energy, that is correct. Sound energy, that is acoustic energy, due to that only we hear sound. Then kinetic energy, again due to the mass and velocity of an object. Mechanical energy includes both potential energy and kinetic energy. So for this particular question, what is the name given to the energy stored in an object due to its position or shape? It should be potential energy, not mechanical energy, because mechanical energy includes both kinetic energy and potential energy. Is that clear, student? So then we'll move on to the next slide. What is the correct equation for the work done? You can remember work done, force applied into the distance moved by the object in the direction of the force. So magnitude of force into the displacement, that is work done. So here, what is the correct equation for the work done? That has to be mass into gravitational acceleration. No. Why? Mass into gravitational acceleration is going to be weight. So this is going to be the weight of the object. That is not the answer. Mass into vertical height to be lifted. No. Mass is not the force exerted. So because of that, it is not correct. Mass into gravitational acceleration into vertical height to be lifted, that is correct. Why? Mass into gravitational acceleration is the weight. Weight is the force that is needed to be applied. So force into vertical height is the displacement. So force into displacement is the work done. Mass into gravitational acceleration into vertical height to be lifted. Then the fourth one, gravitational acceleration into vertical height to be lifted. There also the force is not given. It is only the gravitational acceleration. So the correct answer is the third one. Mass into gravitational acceleration into vertical height to be lifted. Then the next one. An object was moved by 4 meters with a force of 20 Newton. What is the work done? So here the distance moved by the object is given 4 meters. Force is given 20 Newton. You can remember that, students. If there is an object like this, a force is applied, 20 Newton, and this moves a distance of, up to here, it moves a distance of 4 meters. So work done is what? Force into distance moved. So that is going to be 20 Newton into 4 meters. 20 into 4, 80 joules. Newton meters is equal to joules. So the answer should be 80 joules. 40 joules, 5 joules, 80 joules, 10 joules. The correct answer is 80 joules. That is a direct calculation. Work done. An object was moved by 4 meters with a force of 20 Newton. What is the work done? Force into distance moved. That is 80 joules. With that, students, we'll move on to the next question. Fifth one. What is the name of the energy stored in an object when work is done against the gravitational acceleration? So, due to the change in position, it is the potential energy. And here, since the work is done against gravitational acceleration, we call it gravitational potential energy. If we look at the answers, gravitational potential energy, correct. Elastic potential energy, what is that? When you have a spring, if you stretch it, spring, rubber band, elastic, when you stretch it, Due to that elasticity, when the elastic substance stretches, there is potential energy stored. That is what we call as elastic potential energy. Then the next one, kinetic energy. What is that? Energy that is possessed by an object due to its velocity. Energy possessed by a moving object due to its velocity. And kinetic energy depends on both mass and velocity. Then mechanical energy, that includes both potential energy and kinetic energy. So here, what is the name of the energy stored in an object when work is done against the gravitational acceleration? It is going to be gravitational potential energy. Is that clear, students? Then the next question. Sixth one. 48 joules of work is done when an object is lifted to a height of 160 centimeters. What is the force exerted on the object? So here there is 48 joules of work done. Height lifted is 160 centimeters. They want you to calculate the force exerted. So if we represent that diagrammatically, here you have the object. It is lifted to a certain height. If it comes to this point, so here work done is 48 joules. The height is given as 160 centimeters. But you can remember, students, always we need to have the height in meters. So like I tell you, we can do the conversion here and substitute, or substitute while doing the conversion and do the calculation. I'll do the conversion there. 160 divided by 100, that is going to be 1.6 meters. That is the height. Then we have the work done, we have the height, we need to find the force. So what is work done? Work done is equal to force into height. So work done 48 joules. We don't know the force. We know the height 1.6 meters. You rearrange, force is equal to work done 48 joules divided by 1.6 meters height. So that will be equal to 30 Newton. 48 divided by 1.6. 3 times 16 is 48. So 48 divided by 1.6 meters is 30 Newton. So that is the force exerted. If we are to answer the question there. 48 joules of work is done when an object is lifted to a height of 160 centimeters. What is the force exerted on the object? 30 Newton, 15 Newton, 65 Newton, 35 Newton. We calculated the force as 30 Newton. That is the work done. I am sure, students, you all were also able to answer them correctly. So with that, we will move on to the next question. Question 7. What are the factors that affect kinetic energy? What is the equation for kinetic energy? You all can remember. E kinetic equals half mv squared. So this is mass and v is velocity. Kinetic energy is the mechanical energy possessed by an object due to its motion. So it depends on both mass and velocity, or the factors that affect kinetic energy are mass and velocity. If we look at the answers. So these are for the factors that affect kinetic energy, force and velocity. It's not force, it has to be mass. Force and mass, there is no force, effect of force, it should be the mass. Force and the distance moved by the force, no, that is for the work done. Force into distance moved by the force is work done. Mass and velocity, that is correct. Mass and velocity, those are the two factors that affect kinetic energy. Then, fruit on a tree has a mass of 100 grams. The vertical height to the fruit from the ground is 2 meters. Find the gravitational potential energy of the fruit. So here, the fruit is somewhere here, 100 grams. Again, you need to do the unit conversion. 100 divided by 1000, that is 0.1 kilogram. And the height is given to us. This height, let's say from here to here, it is 2 meters. And what is potential energy? E potential equals mgh. And m is 0.1. G gravitational acceleration 10. And the height is 2 meters. So if we multiply that, 0.1 into 10, 1. 1 into 2, 2. So it's going to be 2 joules. That is the potential energy possessed by the fruit. The mass is only 100 grams, but then when we convert it to kilograms, it becomes 0.1 kilogram. If we look at the answers, fruit on a tree has a mass of 100 grams. The vertical height to the fruit from the ground is 2 meters. Find the gravitational potential energy of the fruit. We have found it as 2 joules. So 8 joules, 4 joules, 6 joules and 2 joules. 2 joules is the answer, the correct answer. Is that clear, student? Okay then, I'll move on to the next question. 9. Not an instance of using potential energy in day-to-day life. So if we consider that a man riding a bicycle. When a person is riding a bicycle and the person together, they are moving. So if an object is moving, what is the energy? It's kinetic energy. So there it is kinetic energy. But you can remember, students, if a person is going uphill, what happens? The kinetic energy will be converted to potential energy, and when he is riding downhill, the potential energy will become kinetic energy. But it doesn't say anything about a height. So here it is only the motion riding a bicycle. So it's going to be kinetic energy. Hydropower plant, that you all know. Water reservoir, inside the water reservoir, water is stored at a certain height. Because of that, the water has potential energy. And when the water flows down, the waterfall or the water is running down, what happens? The potential energy is converted to kinetic energy. This kinetic energy of water is converted to the kinetic energy of dynamo, where it is again converted to electric energy. So there we use potential energy. Yes, here we use potential energy. Then pile and tower. You can remember that. What happens? There is the tower connected to the particular vehicle, piling machine, and then you have the pile that is lifted up, and then from that height it is dropped down so that it will go deep into the soil. So there again you lift it to a height so that it can gain potential energy, and that potential energy can be converted to kinetic energy. So there we use potential energy. Then sledgehammer. Again, yes, the person lifts the sledgehammer to a height, then there is potential energy gain, and when it is brought down and hammered onto the sledge or the wedge, the potential energy is converted back to kinetic energy. So there also we use potential energy. So here the question is not an instance of using potential energy in day-to-day life. So that is the first answer. A man riding a bicycle. Then the next one. The power of a machine is 200 watts. What is the work done by the machine in a minute? So there you can remember, students, the equation. Power equals work divided by time. So work is power into time. So power is in watts, 200 watts, and time should be in seconds. Here the time is given in minutes. So 1 minute converted to seconds multiplied by 60. 1 into 60 seconds. So that is going to be 12,000 joules. 200 into 60. 2 into 6, 12. And it will be 12,000 joules. That is the work done. So if we look at the answers, 6,000 joules, 12,000 joules, 3,000 joules and 2,000 joules. So the answer should be 12,000 joules. So this is the calculation, students. They have given us the power of the machine and we need to calculate the work done in a minute. So you all know machine when it is power, it is the work done in 1 second. So although the time is given in minutes, we need to convert it to seconds. So here power is work done divided by time. So work is equal to power into time. 200 watts is the work and power 1 into 60 seconds. There again, students, you don't have to really put the 1. If you directly put it as 60 seconds, that is also fine. So 12,000 joules, and we have selected the correct answer as well. So with that, students, I'm going to end this chapter where I have discussed the miscellaneous exercise from your textbook and some more extra questions. But in the next chapter also, I will continue with some more of these MCQ type questions, and thereafter I will discuss extra questions as well.